June 2020, paper 6, variant 2. Question 1, it's a reaction between hot copper oxide and hydrogen. Okay, this is a redox reaction. Hydrogen is more reactive than copper. It will reduce copper oxide to form copper and steam. Then he asked the first question, draw an arrow to show where the apparatus should be heated. Of course, the copper should be heated, the copper oxide should be heated. You always heat the solid, not the gas. Then he wants the color change. Copper oxide is black and it will change to copper, which is reddish brown, or even orange is accepted. From black to brown. Identify the colorless liquid. Of course, steam is produced from this reaction, as we said. So the colorless liquid is water. And it's condensed by the ice in the beaker surrounding the U-tube. So the purpose of the ice is to condense the vapor into liquid. Question EI, large amounts of unreacted hydrogen should not be allowed to escape. Why? Hydrogen is flammable, also explosive could be accepted. Okay, so you cannot let hydrogen leak. Then he wants a method for collecting and measuring the volume of the gas. Of course, a measuring cylinder is the best way to measure, to collect and measure at the same time. A gas syringe, is the best way to collect and measure the volume of the gas. And the label, don't forget to label the apparatus, gas syringe, and draw it. Question 2 is a displacement reaction between magnesium and sulfuric acid. Of course, magnesium sulfate and hydrogen are released. He's measuring the temperature, the highest temperature reached. Take care, he used a measuring cylinder, which could be an improvement later on if he asked. You should use a burette to be more accurate. And every time he's increasing the length of the magnesium ribbon, which of course will increase the temperature rise of the reaction. This is the table of the readings, okay? Each mistake deduct a mark. 1, 2, 3, 5, 6. 23 is always the initial temperature in all experiments. And then 24, 26, 29, 36, 40, and the temperature increases 1, 3, 6, 13, and 17. A very easy question after it, which one had the highest temperature rise? Of course, experiment 5, because it had 17, which was the largest number. The curve. The blue one is the curve you should draw. Okay, take care, it's a smooth line, which means you don't use a ruler. You should use an appropriate scale for the y-axis. A very important remark is that your graph should always pass half of the y-axis. يعني ما ينفعش إن الجراف بتاعي كان يبقى عامل كده. ما ينفعش يخلص below the half point of the y-axis. Okay. Whenever choosing a scale, keep this in mind. لازم الجراف يعدي النص at least on the y-axis. Each inaccurate point, deduct a mark. If you do the graph with a ruler, deduct a mark. Then explain why the graph must pass through the origin. Lille graph must start through the origin because if there is no magnesium, there is no reaction. I should indicate in لو ما فيش magnesium, no temperature rise will happen. If there is no magnesium, there is no reaction. From your graph, deduce the temperature if I repeated experiment 1 using 4 centimeter length of magnesium ribbon. A 4 centimeter length of magnesium ribbon, you will show your working by these lines, and you will read the y-axis, which will be around 9 degrees Celsius. Fi, why would carrying the experiment in a polystyrene cup improve the accuracy? Take care. Whenever you're doing an experiment and you're measuring the temperature rise or temperature change, you should do it in a polystyrene cup because it's a heat insulator. Okay, polystyrene is a heat insulator. It reduces the heat loss to the surrounding. And if you want a further improvement, you can insulate the whole apparatus. You just say insulate. Okay. Double I, polystyrene is a heat insulator, takes the mark. The word insulator is very important in the answer. Please always say it. Double I, sketch on the grid the graph you'd expect if experiment was repeated using a polystyrene cup instead of a boiling tube. This is very important. What's the difference on the results if I'm using a polystyrene cup instead of a boiling tube? Take care. Polystyrene is a heat insulator, so it will minimize heat loss to the surrounding. The boiling tube is made of glass, so there will be significant heat loss. But when I'm measuring the temperature inside the container, which means in case of the polystyrene, the temperature rise هيبقى أكتر. It will be higher because you trapped the heat inside. the temperature rise will be higher. This is the shape of the graph you should sketch. Starting at the origin, that's steeper than the original graph because you need to show an higher temperature rise inside the polystyrene cup. GI give an advantage and a disadvantage of the pipette. I, it's more accurate. Double I, it's slower. The pipette and the burette have the same advantages and disadvantages. Okay. Question 3, the cations and anions. Question 3, 2 solid analyzed. L was chromium chloride. And now he's starting to do some observations. The first thing is he did the test of potassium manganate solution, which is the test for sulfur dioxide, okay? Sulfur dioxide gas. Type. Nothing will happen because we have chromium chloride, okay? So nothing will happen because sulfite is not available, not present. Then he added sodium hydroxide solution, which is the test for cations. We have chromium ions, so gray-green precipitate soluble in excess. He added excess aqueous ammonia, gray-green precipitate insoluble in excess. Take care, chromium dissolves to sodium hydroxide only. Then in D, he added nitric acid followed by silver nitrate, which is the test for halides. And the first halide we have is chloride, which is a positive result of white precipitate. Test on solid M, he did a yellow flame. He did a flame test on the solid. Yellow flame was seen, but sodium is present. Then he added an acid effervescence and lime water turned milky. So you have carbon dioxide gas, which is produced from carbonate anion. Therefore, the solid is sodium carbonate. Mark for the cation, mark for the anion. A very easy question. Finally, the experimental design. You have 2 window cleaning products made of ammonia, which he's told you that's an alkali that reacts with acids. He wants you to investigate or plan an investigation to show which one had the most concentrated aqueous ammonia. على طول titration. Okay, you want to differentiate between concentration of acids or alkali, you use titration. Take care, you can never use pH or measuring or using universal indicator or measuring the pH because they are the same alkali. You only differentiate between the strength بالindicator أو بالuniversal indicator أو بالpH. If you have a strong and a weak acid or strong and a weak alkali, you can differentiate ما بينهم universal indicator. But هنا you have the same alkali, which is ammonia, and you need to know which is more concentrated. طب titration. First of all, you will add a known volume of ammonia in a conical flask by a pipette. دي أول نمرة. Okay, 25 centimeter cube أو أي volume you like of aqueous ammonia in a conical flask. This is a mark by a pipette. Fill the burette with HCl and add drops of methyl orange to the ammonia. Please always say methyl orange, not universal indicator, because universal is not preferred in titration as it gives many color changes which can confuse the one doing the experiment and make him pass the endpoint. Question 4, the fourth point, add HCl to ammonia till the color changes. And then record the volume of the acid used. Finally, repeat the experiment with the other window cleaner and compare the volumes. أنت عملت titration, you've added the alkali here. خلاص, indicator, methyl orange, مليت البيرات بالacid, and you started titrating till the volume, the indicator color changed. You record what we call the titer volume, or the volume of acid used. You repeated the experiment again with the other cleaner and compared the volume. ما تنساش conclusion في الآخر إن the ammonia solution or the oven cleaner or whatever cleaner that required more acid, a larger volume of acid, was more concentrated. Okay, this was June 2020, paper 6, variant 2 by Mr. Marco Medhat.